Ever wondered how we know if a self-driving car can actually see a pedestrian, or if a medical diagnosis AI is truly accurate? It's not magic. It's a crucial process called model evaluation. This is the step where we rigorously test our machine learning models to see how they'll perform in the real world, on data they've never encountered before. Think of it as the final exam for our AI, determining if it has truly learned or just memorized the answers. Without it, we're essentially flying blind, deploying models that could be ineffective or even dangerous. So, how do we make sure our model isn't just a good student but a true master of its subject? The key is validation. We need to ensure the model generalizes well, meaning its performance on new, unseen data is just as good as its performance during training. The most fundamental technique for this is the train-test split. Imagine you have a big data set. You'll slice it into two parts. The larger part, the training set, is used to teach the model. The smaller part, the test set, is kept completely separate and used for the final evaluation, like a surprise quiz. To make this process even more robust, we use a technique called cross-validation. Here, we divide the data into several folds or sections. The model is then trained and tested multiple times, with each fold getting a turn as the test set. This gives us a much more reliable estimate of the model's true performance. Now, let's talk about the specific grades we give our models, especially for classification tasks like identifying spam emails or diagnosing diseases. The most intuitive metric is accuracy, which is simply the percentage of correct predictions. It's a good starting point, but it can be misleading, especially if you have an imbalanced data set. That's where precision and recall come in. Precision answers the question: of all the times we predicted positive, how many were actually correct? High precision means we are very careful not to make false positive errors. Recall, on the other hand, answers: of all the actual positives out there, how many did we successfully find? High recall means we are good at finding all the true positives. Often, there's a trade-off between these two. To balance them, we use the F1 score, which is the harmonic mean of precision and recall, giving us a single number that reflects both. For a more comprehensive view, we can use the AUC ROC curve. This graph visualizes how well our model can distinguish between the positive and negative classes across all possible thresholds, with a higher area under the curve, AUC indicating a better model. What about when our model is predicting a continuous value, like the price of a house or future stock prices? This is a regression problem, and the metrics are different. One of the most common metrics for regression is R-squared, also known as the coefficient of determination.